Hello everyone, Dr. Doherty here. Welcome back to the Root Introduction Tutorial Studios live at a hotel room outside of Fermilab. Last time we talked about how to get Root, how to run it, how to edit code in a text editor, and to run a macro. So we'll start from there. If you can't do any of those things, please go back to lesson 0, because in C++ we always start counting on 0. Today we'll talk about some code that will help you do all of your homework, presuming that your homework is nothing but plotting functions, and some of the root features that we're going to need as we move on. Okay, so let's fire up Emacs and fire up root and take a look at our code from last time. Okay. Emacs is being a little bit cranky on my laptop, but it runs like butter when I'm on Linux instead of when I'm on Windows. As that's going, let's open up root. So from Linux or Mac, you're going to go to your terminal or your command line prompt. From Windows, let's come here and I'll type cmd. That gives me a command line. I will do cd /root/intro. So Windows has copied a lot of things from Linux, and tab completion kinda works here. Intro 2017. I type dir, and there's our hello.c. When I run Emacs, it automatically saves changes with a file name with a tilde after it. So that hello c tilde is Emacs's one of Emacs's autosave options. And that has gotten me out of many problems in the past before. Okay, so let's open this up in Emacs and see what we're looking at here. So Control X, Control F to open. I'll do Control A to jump to the beginning of the line and Control K to kill off the rest. Roots, Intro 2017, hello.c. And that's going to open up for us. Okay, so now from here I'm going to type in root. And root lady comes up, and let's see if our macro still works. So .x, and I'm going to type in he and press tab, and there's our hello world macro. Okay, if I were to turn this in, notice that I added one thing that we didn't have last time, because if this were homework for a class, it would have failed because it did not have a comment at the top telling us what our program did. So I've added this in. In C++, to do a comment, we do // or if I want a longer comment, then /*, and I can put in long blocks of comments. I can end that up with a // because Emacs is awesome. It's turning comments red for me. Okay, so some philosophy before we move on here. I've been writing root code for 17 years and programming for longer than that. My laptop is littered with literally hundreds, if not thousands, of programs that I've written over the past few decades. You could show me a program that I wrote last month or last year or last decade, and odds are I'm not really going to remember what it does or how it works or how to use it. You will save yourself a lot of suffering in the long run if you have a little comment at the top of every program that you write that says what it is, why you wrote it, how it works, how to run it, what's the input, what's the output. You will save yourself suffering. Now the second thing you're really going to want, not for these tutorials, but to make your life be better in general, is some kind of lab book for taking notes as you go. So either an old school pencil and paper lab book where as you're working, you're writing the programs that you're writing and the parameters that you're running them with and what you're doing and what you're testing, or something electronic where you can copy and paste plots and error messages for working on later, or a blog or a website or whatever your thesis advisor wants you to do. You need some way of staying organized and remembering what you're doing and why. It will save you suffering in the long run. Find a system that works for you. Okay, so now let's actually write something a little more interesting. We're going to start off by having root automatically plot some functions for us. So in the root world, we need to open up a object of the Formula 1 class. Now, when you're going to mess around in root, if you do things from the root command prompt, we can use tab completion to make our life a lot easier. So for instance, I can take a look at what my options are here. So if I want to try this out, I'll start off with F. I like having my variable names match what they are. So for a function or a formula, an F is a good thing. Equals new TF1. Now, two things. First off, I haven't bothered to declare what variable type F is. That's okay. Root's interpreter has my back. I can be a little bit sloppy when I want to. That's all right. Second thing, some root nomenclature. All root classes start with a capital T, and every root variable or root name, except for the few exceptions that are incredibly annoying, has every first letter capitalized and everything smushed together. So for a T Formula 1, I'm going to have a capital T, capital F, and the 1 for a one-dimensional formula. Now in math we'd call this a function, but in C++ functions are something else entirely. Open up parentheses and hit tab. And now I get all the options from my constructor. This is a lot faster than Googling the root reference guide. So we're normally going to want to use the basic ones on top. So constant character pointer name. Now a character pointer is just a text string. Every root object is stored in its internal bookkeeping, so it gets a special unique name. You really want to have this be the same name as the variable name. So if my variable is F, the name for this should be F. Okay, now a formula. Now here I can actually type in something that looks like a math equation, and root can interpret that for us pretty well. So I can do a lot of things. I can do x squared with a caret that I can't even do in C++, minus the sine of x times e to the negative x divided by 2 plus 1. And root can kind of handle that for us. Okay. Now my third and fourth parameters here are the range of my x-axis, x-min and x-max. So let's do this from -2 to 2. All right, it came back and made a object for me. So I've got an object of my TF1 class. So now I want to draw it. Because this thing is a pointer, I need to use the arrow operator for everything that I do. So we're going to draw. Following root nomenclature, the first letter is capitalized, so draw. And there's my function. Okay, really fast, really easy way to plot a function in a few lines of code. Let's go ahead and save this now as a macro that we can use. Okay, so if I come to Emacs here, Control X, Control F, and let's call this, I guess, formula1.c. Okay, comment block. So examples of root T formula class. All right. Now we'll talk about some other ways to do this, but the simplest way for now is to just open up a brace and start going. Now, if you wanted to, you can copy and paste things back and forth from the command line. I didn't really like that function, so let's try a different one. I'll call this F1, because we'll do a few more later, equals new TF1, and let's just do F1. I'll start off with something easy, like the sine of x, from, pick some range, 0 to 5, semicolon, F1, draw. Close brace. Save. My Emacs has been running a little bit slow, so I'm going to make sure that it actually is finished saving, wait for those stars to go away. So now when I run my function, I'm going to have this up. Okay, so .x, f maybe an O, and I'll hit tab, formula1.c, and there's my plot. Alright, now that I have a root plot and a macro to make it, let's see what I can do with this. So going from the left over, going to File, this root plot is called a canvas. So every time I want a new window to pop up, I need to make a new canvas. I can save and I can print, but let's look at some of these default options here. Now the first default root canvas is called C1. So when I save this, it's going to be C1 dot whatever, because that was the name of my canvas window. It can be really handy to save a file with the same name as the macro that made it, so you know where it came from. Okay, some basic options here. When you are saving a plot, you always want to save a picture using the .png or the GIF. Now those output formats are the same. PNG is kind of the open source of the now proprietary GIF format. If you use PNG, no one argues with you about how it's pronounced. If you use this one, you have the whole GIF versus the GIF nomenclature thing, and it's going to start a big argument. What you never want to do is save it as a JPEG. That's a disaster waiting to happen. Let me show you why. So I'll click on Save. Root tells me that it's made one. Okay, so I'll come here, go to my root intro 2017. Let's click on my JPEG. That doesn't look so bad until I zoom in. JPEG compresses things. It's fine for digital photos. It's horrible for line plots. Never, ever, ever save a plot as a JPEG because you get these horrible compression artifacts. Just don't do it. So if I wanted to save this, I would actually save it as a PNG. Now these top two options, PS and EPS, PostScript and encapsulated PostScript, those are really great if you're writing a LaTeX document, like say a PhD dissertation. The bottom two are some interesting cases that we should take a look at here. So let's do this first one. Now .C is the extension for a root macro. So when I click on this, it's actually made a macro. And if I go to Emacs to open this up, so C1.c, this is a automatically generated root macro that would produce this plot from scratch. Now the advantage of this is I get a way to save it automatically. So if I've typed in a bunch of commands from the prompt, or I've run things editing by clicking on them, I can save a copy here. Another really nice feature of this is it shows you what the commands are to do things. So if I look at my line here, it's showing me these commands: set line color, set fill style, set x-axis title font. This can be a really great way to learn how to control the plot settings that you want. So we're going to give this a try in just a little bit. Alright, one more option to look at before we move on. If I click on File and I click on Save, I can save this as a root file. Now anything in root can be saved easily to a root file to be loaded and used again. The easiest way to open this is by coming to my browser here and just clicking on this, and it's going to automatically take that file and open up a root object browser for me. And we'll take a look at this in some more detail later on, but for now all I got to do is click on my root file, and there's one thing in it, and it's this canvas called C1. So if I closed this here, I could reopen it from the root file just by double clicking on it, and it will draw my root canvas for me. There we go. Great way to save things to use later on. Alright, so let's close that up. Let's go back now to our macro. Okay, so that was the file menu. Let's take a look at what else we can do. So over on the view options, I'm going to start off with the event status bar. This is going to make a little bar at the bottom. Sorry if that font is too small for you to see. The window here tells me what it is that I'm pointing at. So when I'm down along the border, I'm pointing at the canvas C1, and if I point at my line, my icon turns to a pointing finger, and it says I'm pointing at the F1 object. Now down here I get the pixels in X and Y and the location of the X and Y axis. This is really great for picking out features of your plot really fast and easily. Okay, so now if I take a look at my line here, I can right-click on it to get a context menu, but an easier way to change things is to open up the editor panel. So I'm going to now go to View and click on Editor. Now, whatever I click on, I'm going to get a menu here on the left that shows me some features to change it. So if I go back to clicking on my function, so here's the options for it. So I could change my line to be purple and really thick and dash dotted. If I click on my window background, I can change the fill color to be something else, and I can change the fill color of the rest of the canvas to be something, and I've made some beautiful art worthy of hanging up in the Brookhaven cafeteria. So now if I wanted to, I could save this as an image or a root macro or root file to come back and edit this later. But now let's go have our macro do some of this for us automatically. Alright, so let's close that so we start fresh. So how do we do it? Well, I'm going to want to use the command to set the line color. If I can't remember what that is, all I've got to do is come into my root prompt and try typing set with a capital S, and if I hit tab, I get a whole lot of things that I can do. So maybe I'll try set line. So now I can hit tab and it will complete to line. I'll hit tab again and here's some options. Color, style, width, attributes. Okay, set line color. Alright, so now I get a way to set my line colors. So let's see what some of these options are. Okay, if I run my macro again, root has an easy way to take a look at the options for our colors. So if I just go to my view and I do colors, it's going to show me the official root color wheel. Okay, in the world of root, all classes start with a capital T, but all constants start with a lowercase k. Now all these are basically numbers, and I can even offset them by these numbers that are given to us. Okay, so for instance, if I want to have a line that is blue, I would use the K blue constant, and then if I wanted this shade over here, I would just type in K blue minus 10. If I wanted this shade here, I would do K blue plus 3. So let's now give that a try. Alright, so I'm going to come back, reopen up our formula macro, and I will do F1 set line color K blue plus 2 semicolon. And now when I run this, I get my pretty blue line. Okay. So this gives me a way now to control what's happening in my plot. This view markers page is also going to be important to us later on, just so you know that that thing exists. Okay, let's continue beautifying this plot in our macro so we can control it. If you turn this into your thesis advisor, you would get it thrown into a tiny ball and thrown back in your face because the title is horrible, and more importantly, there are no axis labels. Let's fix that real quick. So I need a way to set the title. Okay, let's guess. If I go to F1 here and I type set title, there we go. So back to our option, F1 set title, and I will give this thing a title, my function. Now when you're just messing around, it can be really great to type things into your root prompt And then when it's what you want to do, you can always just kind of copy and paste it into your macro until you get the feel for how things go. Now let me show you a cool shortcut that is not widely known in the world of root. There is a hack for changing the X and Y axis titles from the set title just by putting in a semicolon here. I can now type in my X axis title, and I can type in my Y axis title, Y in miles. Okay, and now when I run this again, it's automatically set my X and my Y axis titles to be whatever I want. Alright, so now this is looking pretty official. Let's kick it up another notch. So let's make another function now. So I could say take all of this and copy and paste it, and using the power of Emacs I can change all my F1s into F2s. Alright, now I could have written that out the long way, but where would the fun have been in that? So let's now declare a different function and take a look at how we can plot two functions simultaneously. So let's have this be a cosine. Let's have this line be k red, and I'll call this my other function. And we'll do x in fathoms and y in furlongs. Okay, so now I'm going to run this. And I have botched that because this needs to be a TF1. We'll look at TF2s momentarily. Okay, so now when you've made root really angry at you by, say, declaring a variable of one type and changing it back, and you get interpreter error recovered, safest thing to do is quit and restart. Yeah, I could edit this out of the tutorial, but that's just not real enough for me. Okay, so now I run this. Now all I get is the second function. The first one has disappeared. Well, that's because when I told this to draw, it overrode what was already there. If I want to see them both at the same time, I need to tell it to draw on the same. So I'm going to put in double quotes, the same parameter, and it's going to tell root to take the existing axis on the existing canvas and draw this on top of it. So we will save this and we'll run it again. Alright, coming back up here, and now I double click on my plot. There we go. Now I've got both of my functions plotted together on the same axis. It's going to keep the title and the title axis titles for the original one. Alright, now suppose your thesis advisor says, no, I want these on two separate windows side by side instead of overlaid on top of each other. Let's do that. So if I'm going to do that now, what I want to do is have my own canvas that I can control and set the size of. So let's make a new one. C1 equals new T canvas. And as always, let's double check what my options are here on my root prompt. Open up parentheses, hit tab. Okay. Name, title, and here we're going to use this option that gives me my width and my height for pixels. Alright. My name should always be my variable name. So now I can give a window here, so my root plot, and this is going to be the title of the window, and I can set the width in pixels. If I'm going to do two plots side by side, maybe I'll do 1000 by 500, so I get a nice 2:1 aspect ratio. Now I want to split this up, so I'm going to use the divide command to make this into two separate panels. Let's start off with dividing into 2 by 1. I've always found the divide command to be a little counterintuitive. Instead of doing rows and columns, it does columns and rows. So we'll take a look if we got that right in a second. Now I need to tell root which panel to draw things on. So we're going to use the CD command, like for change directory. So we're switching to the first panel, and now we're switching to the second panel of my window 1. If I made multiple windows, C1, C2, C3, I could use the CD command with C1, C2, and C3 to switch to the different panel on a different window. Okay, so now let's see if this has done what we want to do. Okay, now I've got my number 1 working fine, and number 2 is a horrible nightmare because it was trying to draw on the same axis of a plot that didn't exist. So we'll remove the same, and I'll type this, and now I've got my 2 lovely panels side by side. Okay, if I decide that this isn't big enough, I can come to my event status bar, and I can resize this to be the size that I think it should be. And this panel here shows me the pixels that I'm pointing at right now. So my bottom corner is now at 1596 by 707 pixels. So I could come and I could round this up to 1600 by 700 pixels, and that would give me the size that I had before. I get this perfect, I could then save an image or save this as a root file or a root macro to come back to. Alright, let's do one final thing before we call this a day. Back to Emacs. Let's now change the aspect ratio a little bit, and let's do 3 instead of 2. And let's make a 2-dimensional one to fool around with. So switching to the third panel here. F3 equals new TF2. So now I'm going to have a 2-dimensional function. I get to use x and y instead of just x. And we can always check the options here. Name formula, xmin, xmax, ymin, ymax. Okay. So I'll have a formula, 10 times the cosine of x times the sine of y. And x can go from -3 to 3, and y can go from 0 to 10. Now, when I draw this, we get a whole new set of options for our 2-dimensional surfaces instead of our 1-dimensional line plots. So I'll start off by just saying draw, and we'll see what happens and take it from there. Okay, I can execute this. Now I've got 3 panels, and I've got my untitled function and my untitled x and y axes, and it's made for us a contour plot with a red line. If I right-click on this, I can go to Set Draw option, and I can pretty quickly change to some other things. So let's take a look at some basics. The most commonly used ones are the surf function, and there's a few options here, but let's do surface 1. Now I get this surface. It's kept the red line color from before, so if we don't like that, it's pretty easy to change by doing the set line color to black. I have this now rotatable 3-dimensional view. If I come up to my canvas here, I can right click and I get some options for front, side, top that can rotate this nicely. Also, if you really want this to look cool, I can go to View, View with OpenGL, and it will bring up the hardware accelerated 3-dimensional surface that's got lights and shading and hidden surface removal and cameras. I can do a lot of really cool things with this. Okay. Another really popular option is the sort of top-down view, so the Col Z. If I do the Col Z, I get this top-down view, and my Z-axis, the height of this plot, is now shown on this color scale over here. We use this a lot to precisely tell what's going on. And in fact, if I go to the event status bar and I point at one of these, it tells me on the bottom of the screen which X and Y values I'm pointing at and what the height is at that particular point. Now you want to see what these other options are? Well, let's go to Google. A few seconds of Googling gave me a pretty quick option, so I did root TF2 draw options, and what we want to look at is this T-Hist-Painter class reference. So options for 2D histograms, and here we go. So coals, candles, violins, contours, cylindrical polar coordinates, surfaces. You can have fun playing around with all those various options. So I can pick one that I like. We can fool around with all these until I get something that I think is worthy of showing off. And then when I'm happy, I can just sort of save this to my macro and we can call it good. Let's try a surf 2. All right, that's lovely. So when I get one I like, I can just come back here and do draw surf 2. And to make this official, we will set title, surface, and we'll give it a X and a Y title placeholder. All right, save and run. Okay, so for today's lesson, we looked at the root T formula class, TF1 and TF2. We saw how to deal with the plot windows, how to change things like line colors and fill colors, both by clicking on them in the editor, right-clicking on them, and by saving the commands in the macro. And while we want to save things as a PNG or a macro or a root file, and never as a JPEG. In the next lesson, we'll do some formulas that have unknown parameters, how to fit those to some data, and we'll really start writing some cool stuff. See you next time.